We're talking about cosecant, secant, and cotangent, all right? Cosecant, secant, cotangent. We're going to graph all of these from 0 to 2 pi unless we are asked to do something else later on in the book, and we might be able to do that. But for right now, I'm just going to introduce the basic 0 to 2 pi part. So remember, what is the cosecant the inverse of? Who knows? The sine, right? Yeah. So we know that the cosecant is equal to 1 over the sine of x, right? Cosecant of x is 1 over the sine of x. So we're going to start then by taking a look at the parent graph of the sine function. So take your ruler, give yourself a nice sine curve. And we're going to go from 0 to 2 pi. So I'm going to start with pi over 2, and then mosey over to pi, and then 3 pi over 2, and then 2 pi. And my black graph here is going to be the sine of x. All right, so take one color and graph the sine of x. I'll go up to 1. Actually, no, I'm going to go 1, 2, 3, and then -1, -2, and then -3. So I'm going to go up and down to 3, and you'll see why in just a minute. So just like we practiced at the beginning of class, the sine curve has those 5 basic dots. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and then 2 pi 0. So we're going to grab a nice smooth sine curve from 0 to pi over 2. So far, so good. So let me ask you a question then. Since the cosecant is 1 over the sine of x, what do we always need to be very careful of when we have a fraction right down here? We can't divide by 0. Okay? So I can see 3 spots on the graph where the sine curve is equal to 0. Can you see them? Yeah, give me one of them, Anthony. Isn't the thing on the top wrong? No, it says that 0 is included in my thing that I'm working on here. No, I'm just looking from 0 to 2 pi. I could look from -2 pi to 2 pi. I could look from. I'm just looking in one specific spot because that's just one cycle. Okay. Remember, the domain for sine and cosines are all real numbers. So if I'm just looking at the sine for right now, I can have everything in there. I'm okay. Even 0. Okay, so let's get back to the question here. Where does the sine curve equal to 0? There's 3 spots. I'm looking at them right now. Can someone help me out? Yes. Yeah. So this is where sine equals 0. This is where sine equals 0, and this is where the sine equals 0. So if the sine equals 0 there, what is the cosecant going to have going on at those points? Yes, I'm going to have vertical asymptotes at those points. So in red, I'm going to do these in red to show you that at 0, at pi, and at 2 pi, I'm going to have a vertical asymptote there because I'm not allowed to divide by 0, and the cosecant function is the reciprocal of sine. So wherever the sine is equal to 0, the cosecant function is going to be not defined. Does that make sense? Okay, very good. So let's break this down into quadrants now. Consider all of this from 0 to pi. That is quadrant 1 and quadrant 2. You guys agree? Hello? Yes. Then this is quadrant 3, and then finally quadrant 4. So I have all of my quadrants sort of going for me there, right? In quadrants 1 and 2, the sine function is positive because it's above the x-axis. And if you have a positive number, someone give me a positive number. Yell out a positive number. 3. Good. 3. 183. Take the reciprocal of your number that you just shouted out. And is that number still positive? Yes, it is. So the reciprocals of positive numbers are positive, right? So in the first and second quadrant, the cosecant function is going to be the reciprocal of everything we've got going on here, but it's still going to be positive. So it's going to look like this. Right? Say what? Yes. In quadrants 1 and 2, your sine values are positive. If you take the reciprocal of a positive number, you still have a positive number. So everything in quadrants 1 and 2 for cosecant will be positive, but it has to be squished between 0 and pi because I've got asymptotes at 0 and pi and 2 pi and multiples of pi. Okay? So take that same knowledge, and what's it going to look like in quadrants 2 and or 3 and 4? What do you think? You got it. Everything that's negative is going to be negative, so it's going to look down like this. So the blue graph is the graph y equals cosecant of x. Okay, so I could ask you a bunch of questions now about this. So I could ask you, on what intervals of x is your cosecant graph increasing? Where, on what intervals for x is your cosecant graph increasing? I'll highlight one for you. It's increasing from here to here. What is that range? What is that from where to where? There you go. So everything right here, right? So from pi over 2 to pi, this would be an increasing spot, right? So from pi over 2 to pi, it's increasing. Where else is it increasing? Yes, very good. Nice job. So right here, it's also increasing from pi to 3 pi over 2. So from pi to 3 pi over 2. And notice we use parentheses around those. All right? We use parentheses around those. So where are the two places where it's decreasing then? 0 to pi over 2, it's decreasing here. And where's the other one it's decreasing at? Over here it's decreasing, okay? So you can kind of get a lot of information out of that. All right, let's take our calculators, and I'm going to show you how to graph this on the calculator and make your screen match exactly what we have drawn. So just like before, when you're graphing trig functions, make sure that your calculator is in radian mode. It has to be in radian mode, otherwise it won't work. All right, so we're going to go to y equals, and we are not allowed to punch in the cosecant. There's no cosecant button, but there is a sine button. So we're going to graph the sine first, sine of x, and we're going to change our window to match the window that we've created on our notes. So we're going to go to window, and we're going to go from 0, our lowest max. Where's our x maximum? Where are we going to? To 2 pi. So please punch in 2 second pi. What's the scale we're using? What's the increments that we're going up by? By pi over 2. Very good. So second pi divided by 2. Good job. 2. There we go. How low on the range did I go? My lowest y value? -3. Good. And then up to, how far did I go? 3. So if I hit graph, I should see just one nice smooth curve for the sine function, and that matches my picture so far. Okay, now let's go back to y equals, and let's punch in, how do I punch in a cosecant? Yeah, I have to go 1, I have to use the reciprocal function. I have to take 1 divided by sine. The sine to the -1 means inverse sine. That does not the same thing as cosecant. So here we go. I'm going to go 1 divided by the sine of x, and then close my parentheses. And when I push graph, I should see this beautiful picture where my asymptote's right in the middle and on the left and the right. You can see the calculator matches exactly what we have on our paper, so we can check to verify that we're graphing things correctly. All right, here we go. So let's talk about the secant function, right? The secant is 1 over cosine. So the first thing we're going to do is we're going to graph a cosine graph to give ourselves a reference point. So the cosine of 1, according to our beautiful graphs that we did earlier, is 1. So we have this graph, these 5 points for the cosine. There we go. There's 1 full period for the cosine graph, right? Goes from 0 to 2 pi. Okay, now you have to ask yourself, when is the cosine of x equal to 0? I can see 2 places on the graph where they're equal to 0. Can someone shout them out? Pi over 2, yes? And 3 pi over 2. So what happens to the secant curve at pi over 2 and 3 pi over 2? You've got asymptotes, right? And the reason for those asymptotes is because why? Because you can't divide by 0. There you go. You got it, okay? So if we take that same logic as last time, we can say, okay, well, take the reciprocal. It has to be going up this way and hitting the asymptote. Has to be going down like this and hitting the asymptote, down like that, hitting the asymptote, and then the reverse or the inverse of that going up. So my blue graph is the secant of x. Okay, so now we could ask you a lot of questions about this, right? The range is the same as the cosecant. The range is everything greater than 1 or less than -1. The domain is everything except for pi over 2 or 3 pi over 2 or odd multiples of pi over 2. And I could ask you, where is this function increasing? On what interval for x is your function increasing? I can see two of them. From what?
0 to pi over 2.
Yeah, from 0 to pi over 2, so right there. And where's the other one?
Pi over 2.
And from pi over 2 to pi, it's also increasing. It's decreasing here, right? And it's decreasing here. So from pi to 2 pi, it's decreasing. So you got increasing over here, and you got decreasing over here. Our window should still be the same, right? We have the same exact window, so all we have to do is change sine to cosine. So just change that to cosine. And then change 1 divided by sine to 1 divided by cosine. And that should introduce the graph for us the exact same way that we've got it going on over here. So the first curve is the cosine curve. And then I've got my secant curve with asymptotes at pi over 2 and 3 pi over 2. And I can get a lot of information. So since we're going to go from 0 to pi, we need to space it out a little bit differently. So if this is 0, I'm going to go and call this 1, 2, 3. So how about, let's go pi over 4. And then let's go pi over 2. And let's go 3 pi over 4. And then pi. So this is only, since the period is different for tangent and cotangent, the period is only a distance of pi. We're going to do one full cycle here. And I'm going to go up quite a ways. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So let's approach it this way. I have sine on the denominator. So I have to ask myself, when is the sine equal to 0? And we can answer that question by looking back at the first box that we did. This is my black sine curve. When was the sine equal to 0? At 0 and pi and 2 pi. But since I'm only focusing on 0 to pi, I know that at 0 I have to have a vertical asymptote, and at pi I have to have a vertical asymptote. Okay? Now, also, remember, on the unit circle, all right, 90 degrees, if I'm talking about pi over 2 here, is the point 0, 1. X and y. X deals with cosine. Y deals with sine. So if I'm going to figure out what's going on at pi over 2, the cotangent of pi over 2, I can just take the fraction of cosine divided by sine, which would be 0 divided by 1, which would be how much? 0. So at pi over 2, the halfway point, I know I'm at 0. Now I have to just figure out which way this graph is going. Is it going up to down from left to right, or down to up from left to right? So let's figure out pi over 4. Pi over 4 is 45 degrees. So what is the cosine of pi over 4? Root 2 over 2. What's the sine of pi over 4? Root 2 over 2. What's the quotient of those two things divided by each other? 1. So at pi over 4, cotangent must be 1. So what am I going to ask you now? What question am I about to ask you? Yeah, 3 pi over 4, right? What's it going to be? -1. Very good, very good. So here's what I got going on, right? I have this graph. It looks kind of like this. And I've got the two asymptotes on either side between 0 and pi. All right, and I'll show you. I'll bring it up on the calculator. Huh? And this is the cotangent curve. Yeah, you got it. So I'll bring up I'll clear the first one out. I don't need that one anymore. And I'll just go 1 divided by tangent to get cotangent out of it. But I do need to change my window. I'm going to go from 0 to pi now, so second pi. My scale is going to be pi over 4, so second pi divided by 4. My y minimum, I can leave them at plus or minus 3. And then when I hit graph, I can see that my screen matches exactly what